Hello everyone, we are Team Juliet and our project provided by G Research is resilient and rapid Raspberries. Our initial design brief was very open-ended. We were provided with a day's worth of New York Stock Exchange data from 2011 and tasked with designing a system to aggregate and visualize this data. We were provided with a Raspberry Pi cluster to help us achieve this. The brief outlined three major focus points, which were performance, resiliency, and distribution. In today's world of high-frequency trading, you can see up to 50,000 updates per second, so our system will need to deal with that sort of throughput. Hardware failure is also a real problem, meaning that cluster nodes can fail at any point. Again, our system would need to be able to recover from these events happening. We also wanted to fully utilize the computing power of our cluster, and as such, the system would need to be able to parallelize computationally expensive tasks to distribute throughout the cluster. So we opted for a central database design to keep as minimal state as possible on the Pis. This is the input data stream. It's worth noting that this system would work if it were connected to the live New York Stock Exchange data. The files sat on a master PC. This is distributed out to the cluster, which commit these updates to the database. If a user comes along to use our system and initiates a page request on the web server, we send a query over to the master PC. Now, this query may involve processing which we want to do on the cluster. So the distributor will send out this query to the cluster. That will produce results. It's aggregated on the master PC, sent back to the web server, and then forwarded to the client. We face a number of challenges during the system. So due to the distributed nature of a cluster, we cannot guarantee that messages are going to be committed to the database in the same order they were in the original stream. Because of this, we had to develop some database procedures to take into account packet timestamps and sequence numbers so we can recover the original order. We also face a number of performance issues. It's very hard to get a system with limited processing power to do 50,000 updates per second, and the database very much becomes a bottleneck with all of the Pis trying to get at it. So I was going to show a live demo, but the Wi-Fi is really bad, so we've got some backup screenshots instead. So this is the status page. One of the things that the client mentioned to us was that these systems need to be able to monitor themselves. As a trader, you can't be making decisions on out-of-date or incorrect information. So we've developed a number of procedures to monitor the system, and the results are displayed on the settings page, the status page. Up in the top right-hand corner, you can see we have a current system time. Now, this is New York Stock Exchange local time. We also have a list of connected nodes. If the node were to fail, that would be automatically reflected in that list, and you could see straight away what's happened. These two graphs are showing the system throughput, which is packets processed by the system per second, and system latency, which is the time taken for a packet to traverse our network. We take a look at a stock. You're presented with the stock's current order book. Now, the offers table is showing people saying, I'm selling this amount, these shares for this amount, and the bids table is showing people saying, I want to buy some shares for this amount. As you can see, orders are being updated in real time as they're added or removed from the order book. At the top here, you can see some generic statistics about the stock. Now, this is actually processed on the Pi when you initiate the page request. If we move over to the stock price tab, we can see a number of different graphical formats of stock price. So this is just a simple stock price over time graph. This is a candlestick graph, so this is very information dense. It allows a trader to get a lot of information very quickly. Each of these individual candles is processed on a separate Pi. So when you initiate a page request, we're sending out a distributed query to the cluster, the results of which are aggregated on the master PC before being sent back and rendered in our browser. We also have a moving average graph. Again, this is a distributed cluster query. Okay, so, in conclusion, we've developed quite a feature-rich system, which in theory could be connected to the live stock exchange and used as part of a trading platform. Thank you for your time.